So this is just a walkthrough of the Year 12 test that was a few days ago for the people who don't go to the school that I currently teach at. This is just a test that some Year 12s took, the entire year group. It's quite a nice test. It's based on like the first half of AS Maths. We start with this question here, and I don't want to be put on the record about this, but if you see a question that has k in it, about a quadratic, I would bet all of the money in my current account that that is a discriminant question. And it is in this question. I have no idea why that is. There's nothing that makes k about the discriminant, but it is. This is a discriminant question. B squared minus 4ac is less than 0 to have no real roots. They just like choosing k for this question. Anyway, b is 4k, so that's 4k all squared, which will make 16k squared eventually. A is k and c is 3. We get this here. We can factorize out of 4k from that, which of course means our critical values are either k is 0, which will make this whole thing 0, or k is 3/4, which will also make this whole thing 0. So those are our critical values. We want to be less than 0. If you need to draw a quick graph to get your head around this, you've got roots at 0 and 3/4. This graph is less than 0 in between the two roots. Just generally, if you're less than 0, you're in between the two critical values or roots. If you're greater than 0, you're going to be either side of them, assuming the graph is this way up, which it is in this case. If it's upside down, it's the other way around. But anyway, so we're going to be in between the two roots here. Now, almost everyone in the year group just stopped here and put a little dash here and hoped that for some reason this dash is okay and just is fine. But that's not, right? Because discriminant for no real roots is strictly less than 0. If it was equal to 0, that's one real root, right? Or a repeated root, usually called. So where does this equal to come from on this side? And this side only. Like, it's unusual to see a mismatch in inequalities here. Well, and this is, I think, the difference between A-level and GCSE is that just sometimes in A-level you actually have to put forward some critical thinking. Like GCSE, you're just going through methods that have probably been taught in lesson time. But we just have to think through this and go, okay, well, where does this equality come from? Where does this equal sign come from here? And you look at this and you go, okay, well, this set of numbers here, everything between 0 and 3/4, is basically the same as this set, except for one value, which is 0. That's the only value that this set includes that this doesn't. So let's just test what happens when k is 0. Just check by hand. That's only one value. It's not going to take that long to check one value. So check what happens when k is 0. We get 0x squared plus 0x plus 3 equals 0. And there's no roots to this, right? Whatever you try and put in to x to try and make this work, nothing will work because these zeros just make x irrelevant. You just end up with 3 equals 0 every time. So there are no roots when k is 0. And you just need to explain that. And now you can change your inequalities to be what they wanted you to show. So don't just hope that just the signs don't really matter. They do. It's A-level maths. Like, it's not that slapdash. You've got to think it through a little bit and get it done. And you know, if you're missing a value, just check it by hand, right? Anyway, question number 2 is much more friendly. Just take this one and rearrange it, add 3x, and then divide by 4, and we get gradient of 3/4. And then we take this one. I think most people just learn y2 minus y1 equals x2 minus x1. I tend to just draw a very quick picture and just do rise over run, but that's just me. You get this, just remember 8 minus minus 1 will be positive 9, right? And then this is more usually written as minus 3 over 2. These two gradients don't match, so they're not parallel. The two lines aren't parallel. And they also aren't each other's negative reciprocals, so they're not perpendicular either, and so the answer is neither. It's probably best to be safe and give a full explanation. You've got plenty of time when you do papers like this, so just give a full explanation, give the examiner no reason not to give you full marks. So here we probably want to write this in power form to make it integrable. So that's x to the power half, of course. Then we increase this power to a 4 and divide by 4, which just means timesing that by 4 to get a 12. We increase that to 3 over 2, and now I always just times by the reciprocal. So 2 over 3, I mean, it's KFC, isn't it? This should be 6 divided by 3 over 2, but just change the sign to a times and flip this over, so it's 6 times 2 over 3. 1 integrates to x, and then always please remember the plus c, otherwise you lose 1 mark that you really, really should have got. This tidies up to this, and you're done. The next question, very easy. Start dy by dx is just this, 2 times 3, and then lower that down. 2 times 2, lower that down to a 1, and that's just there, and that goes away. Increasing functions. Now, the textbook gives the definition that for an increasing function, dy by dx is greater than or equal to 0. I disagree with this. I think it should just be greater than. But what do I know? I've read the mark scheme very carefully. You're allowed in A-level maths to say either. You can say it's greater than or equal to, or just strictly greater than. It's up to you which one you want to go with. I'm just going to go with what the textbook says. So okay, we set this to be greater than 0. You can just type this straight into a calculator to find critical values if you want to, but otherwise just divide by 2 and it actually factorizes, and you get critical values at 1 and minus a third. This is the opposite case to the first question where the quadratic was less than 0. If we're greater than 0 and it's still a U-shaped quadratic, we want to be either side of these two critical values. Draw yourself a picture if you need to be sure of that, but we're going to be less than this one and greater than this one. In set notation, it looks a bit like this. Just some curvy brackets, x double dot, and then this, and then x this. There you go. Yeah, cool. Next question. Yeah, this question wasn't really supposed to be here. Apologies for that. I mean, apparently all of you have done chapter 10 anyway, so maybe it didn't make too much of a big difference, but yeah, this was a bit of an oversight. You draw a triangle. This is also actually legitimately just quite a hard question, even if you have done chapter 10, which is why very few people got it anyway. But yeah, this is what the picture says. Area is 15. From chapter 9, half AB sine C is the area. A is 10, B is 5, C is theta, so we can put that in, and the area, of course, is 15. Just, obviously, this is 5 times 5 is 25, divide is 3/5, it simplifies to. So that's 2 marks that are quite easy to get. Now, how do we get to cos theta? Now, there's actually a bunch of ways of doing this, but the textbook way of doing it that you really want to see is saying cos squared plus sine squared is always equal to 1, and then plugging in sine squared and then solving for cos squared. So square this out, take it away. This is 25 over 25, take away 9 is 16 over 25, square root. And remember, when you square root, you get plus or minus every single time you take a square root, which is where 2 possible values of cos theta come from. There were other ways to do that. You can literally just do sine inverse of 3/5 to get theta, and then just type in cos of that theta, and as long as you've used, obviously, the answer button, you'll just get 0.8000 or 4/5 even if the calculator is good enough, so you know it's just 4/5. The other thing, and I'll just mention this because this will come up in mechanics a lot later on, either in year 12 or year 13, is sine of theta is 3/5 means it looks like this. Like just from year 8 SOHCAHTOA, sine of theta is opposite over hypotenuse, 3 over 5. But of course, 5 squared minus 3 squared is 16, which is it's the 3, 4, 5 triangle, isn't it? So cos theta must be 4/5. You do that trick a lot in mechanics, just because it saves you a lot of time if you know how to do that. It doesn't get you the minus 4/5 case, but it will get you most of the time. Good. Anyway, so we have cos theta is plus or minus 4/5. BC is the longest side of the triangle. Now clearly we're going to have to do some cosine rule here because we've got 2 sides and an angle now. We could do cos inverse to find the angle, but I'm not going to. This is cosine rule. And now it wants BC to be as long as possible. So, okay, the question is, which value of cos theta do we use, 4/5 or minus 4/5? And one way to think about this is, if you just use 4/5, you're going to be taking away all of this stuff, right? Which in turn is going to make BC smaller, because you have this is 125, isn't it? Minus something square rooted. But if you use minus 4/5, this minus cancels with that minus, and you end up adding in a bunch of stuff. And so b squared is going to be bigger. It's going to be 125 plus all this stuff. And it ends up being root 205 when you do that. So just a bit more critical thinking required there to get that right. So now we have a nice circles question. So these are 2 points on the circle. They're the diameter, which means the radius is in between. Sorry, the center is in between them. So just average the x coordinates, average the y coordinates, and we get 1 mark for that. Good. Equation for C. So the center is 3, 6. So it's x minus 3 squared plus y minus 6 squared. The radius we need to find though, so let's just draw ourselves a quick picture. We know the center is 3, 6. Should be a comma there, unfortunately. I've just mistyped that. Oh well, doesn't really matter. There should be 3, 6. The radius here between the center and the point 81, well, we can just do some Pythagoras, right? It's for the y coordinates is 5 down, and the x coordinates say it's 5 across. 5 squared plus 5 squared square rooted is 5 root 2, the calculators say. So that's the radius, and I'm just going to write that equal to r squared at the end here. This is always how I write the equation of a circle when it's here. It says an equation, so it's not going to be specific how you do it. You could even expand all this out, and you could say this is actually 50, which it is, but I always just write it like this with r squared here. To verify that point lies on C, so just put in 10 and 7, and we get this, which is equal to 50. And I've already said this is 50 squared, so therefore this is equal to this. And you can just write it like that and you'll get the marks. That's good. Find an equation of the tangent at C at 10, 7. So 10, 7 is on the circle somewhere, so maybe it's up here. And when you want to do these questions, you always want to find the gradient of the radius from the center, obviously, to that point there. Now the reason you want to do that, and I haven't really got space to do a quick little triangle there, but I can just say the rise is 1 and the run across is 7, so this gradient is going to be 1 over 7. So that's just 1 up and 7 across if you just read the coordinates. The reason you want to do this is because the tangent, which looks like this, meets the radius at 90 degrees. That's GCSE circle theorems. And if it meets the radius at 90 degrees, that of course means the gradients are negative reciprocals. So the gradient of this line is minus 1 over 1 over 7, which is minus 7. And now we can just use y minus y1 equals mx minus x1 because we have a point on the line. So y minus 7 equals minus 7 times x minus 10. And we have this y minus y1 equals mx minus x1. And we just expand this out and we add the 7 to both sides and we get our answer. I think we've only got 2 questions left. This is a differentiation question. And you know that because of this word, and this thing. If you ever see this, or this, there was a bunch of hints here, you must differentiate. They will never ask you to do this without you previously having earned marks for doing dc by dv. So lots of hints here to just start differentiating. Write it in a form that you can actually differentiate, and then differentiate. Even if you have no idea what's going on in the rest of this question, just do that, and you'll get some marks. Minimizing means setting the derivative to 0. It means something else as well, which we'll cover at the end here, but firstly we need to do this. So we set that to be 0, we can add this to both sides to get this. You can divide by 1500 and you get that. Now there's a lot of ways to do this, including you could write this as 1 over v squared and then do some cross multiplying and square rooting. What I like to do is just say, well, I want v equals, and v is the same as v to the power 1. So I just want to make this into a 1. So if I just raise both sides to the power minus a half, minus 2 times minus a half is 1. So I'm going to get v equals, and I can just type this into a calculator, and I get v equals that. So that's just how I like to do that. Of course, also need to find the minimum cost of the journey. So that's the value of v that minimizes it. That's apparently the speed that we have to drive to minimize the cost. But what is that minimal cost? Well, we just plug this v into there. Just use the answer button in your calculator, and you get this answer here. Prove by using this that it's minimized, so we obviously need to find this, so we take this and we differentiate again. Minus 2 times a minus makes a positive, then we get 3000, and then v to the minus 3. And then this is a constant, so it derives away. And we need to plug in this value here, right? Because this is the value, the value we found in A part 1. Bear in mind also, if you got this wrong and you put it in here anyway, you get marks for error carried forward. You still get marks even if previous bits are wrong, as long as you're doing the right thing. But anyway, we put this into here, and we get 3000 times this minus 3. You can type that into calculator if you really want to, and you get this, which is bigger than 0, so it is minimized. Notice how you didn't even need to remember that rule, because it's telling you that. So you just find this, and even if you can't remember whether minimum is greater or less than 0, you just blag it, right? Because they've told you it. So you just say, yeah, I know what I'm talking about. It's greater than 0, therefore minimum. State one limitation of the model. I mean, there's so many things, but steady speed, like imagine driving from London to Newcastle and going the same speed the entire way. I mean, what even is that? There's hundreds of things you could have written there. Also, just like I said before, bear in mind, even if you had no idea what was going on in this question, you should have got this mark, right? Because this is not a hard mark to get. Like, how ridiculous is it that you would drive from one place to another at the exact same speed the entire way? What, no roundabouts, no setting off, like ridiculous. Anyway, you should have got this mark. Last question here, and I really like this question. I was the one who put this test together, and this was my favorite question on it, just because I think it's very indicative of what AS and A-level papers look like, where if you look back in this paper, all of the questions are broken down into like 2 marks, 3 marks, 4 marks, and all of those add up to make the whole question. And the reason it's broken down is because it's telling you what to do in each part, right? Like if we look at this question here, it's broken each part down for you. This one's not such a good example, but certainly the circle thing before it, where it's broken it down into these parts that allow you to walk your way through the question. But the last question is kind of, in AS and A-level papers, always, that doesn't so much happen, right? They just bang out 10 marks here, and they say, just do it. Just come up with the whole thing yourself. And so, yeah, this is good. This is good practice. And the first thing we need to do, not to sound too much like an English teacher, but we need to come up with a plan, right? We need to think to ourselves first, before we do any actual maths, how are we going to approach this question? Like, we need to find this area here. What are we going to do that? And now, this is where practice comes in, but to me it's exceedingly obvious that we should break this area down from here, right? Because now this area is just underneath this curve, so my plan will be to find this area by integrating this curve between here and here, or here and here really. And then this is just a triangle, so I'm just going to find the area of a triangle. Now that's not the full plan, there's lots of things for me to do there, but that seems like the thing that I should be doing. And again, I can see that instantly because I've just done lots of questions like this before. Now they've told you this is the point 46, which is really helpful because the x-coordinate is 4, means that it's 4 here, and now I can just immediately find this area, right? I can integrate this curve between 4 and 2. Right, and that will find this area here. I've written this in the form x minus 2, so I can integrate this. You can just type this into a calculator, of course. Modern calculators do this. If you want to be fancy, you can actually do it by hand and work out all these powers yourself, like I did, because I just don't have a calculator to hand right now, so I just did it like this. But yeah, you could just type that in, write the 10 into here, and move on. Right, now we're going to move on to this triangle. So let's think about this triangle then. So okay, well, this 6 is really helpful, right? Because 6 is the vertical height of this point here, which means this length here is 6. So actually, I have almost everything I need for this triangle. I need half base times height. I have the height, I just don't have the base. So this is the key point here, right? Like, because if I just knew the distance from 4 to this point here, that would be the base of the triangle. So I just need this point, the point where this line crosses the x-axis. So I need to know something about the line. Right. So I'm just pushing the problem back further and further back. I've decided I need this triangle. Having this triangle means needing this length. Needing this length means knowing something about this triangle. About this line here. So okay, what do we know about this line? Well, basically nothing right now, except that it goes through 4, 6. Let's go back to the question. There we are. The line L is normal to C, so perpendicular to C at this point. So it makes a right angle with the curve. So that gives me my new plan or sub-plan for this question, which is, okay, if I knew the gradient of the curve here, I could negative reciprocal that, get the gradient of this line. If I knew the gradient of this line, y minus y1 equals mx minus x1 will get me the equation, and I think from the equation I could find this point and therefore have my whole thing. So that's the entire plan now. I have everything I need. So let's differentiate this curve to find the gradient at this point. So let's take this curve here and differentiate it. This is 32x to the power minus 2. Minus 2 times 32 is minus 64. Bring the power down. 3x, just differentiate 3. Put in the point x is 4 because I want the gradient at 4. So put in x equals 4. You can be fancy here with non-calc. 4 to the power minus 3 is 1 over 4 cubed, which is 1 over 64. Minus 64 times 1 over 64 is minus 1, plus 3 is 2. Good. So the gradient of this curve is 2 here. Now this line is normal to it, or perpendicular, so the gradient of this line is minus 1 over 2. And now I can just do y minus y1, which is 6, equals m x minus x1, which is 4. Expand that out and tidy it up, and we get this. That's the equation of this line. And now, if I'm looking for this point here, at this point, the y-coordinate is 0, right? I'm not going up or down. The y-coordinate, when I'm at this point here, is 0. So let's set y to be 0 and solve this. We get x is 16, so this is 16 here, which means this distance is 16 minus 4. The plan is all coming together now, and now we have a half times 6 times 12 for our area of this triangle. It's just a half times 6 times, is half 12 for 6. 6 times 6 is 36. This area is 36. Add it to the 10, and we get our answer of 46. Thank you for watching. I hope that was helpful, and good luck the next time we do something like this.